Hello and welcome to today's lesson, which is volume working backwards and shapes with the same volume. Now these questions usually come up towards the end of the higher paper, or maybe towards the end, middle maybe, towards of the higher paper. They do come up maybe sometimes in the foundation paper with some of the easier questions. They can come up anywhere really, to be honest. So let's have a little look at these first of all. So, first thing I'm going to do is I want us to know, we've done a lot of volumes recently, I want us to think about all the volumes that we know, okay? So here we've got the volume of a sphere, and if you haven't got these down, it's probably worth getting these down in your notes. Remember, the only way to learn maths is to do it. So, we've got our sphere, which is this one, and the volume for this one here is volume is equal to 4/3 pi r cubed. We've got our cylinder, which is just another way of doing our prisms. So we know it's the cross-sectional area, which is this part up here, this part here, times by the depth. In this case, we'll call it h. So the volume of that one is equal to pi r squared h. Okay, we've got our cone. If you saw the video on cone, what we're looking at here is we know that a cone fits into a cylinder. If these two are the same, this would fit into here 3 times. So we've got our radius here, we've got our height, which is here, and the volume of this is very similar to this, but it fits in 3 times. So it's going to be pi r squared, so the area of the base, times by the vertical height, because it fits in 3 times, divided by 3. And we've also got this one here, which is very similar to what we've just done. Pick a point above, rhombus, pick a point, and then connect them all up, like so. If this is our vertical height, I'll do it here just so it's a little bit clearer. Can do it from the centre if you want. Okay, if that's our vertical height, and we know that this is x and this is x, it'd be the area of this base, so the volume is equal to the area of the base times by the height, all divided by 3. In this case, it would be x times x, which is x squared, times by the vertical height, h, divided by 3. So we've got 4 different types of volumes there. Now we can have variations of that. We could have a hemisphere, so this would be all over 2. We could have anything at the base of that, in which case this formula here would change. We also have, on the next page, this one here, which is the volume of a prism, is the cross-sectional area times by the depth. So this could be a triangular prism if you wanted it. So connect all those up, in which case this would be your base, this would be your height, and this one here is your depth. So the area of the cross-section, which is this part here, remember with a triangle, let's put a line there so you know these two are separate. With a triangle, it's going to be base times height divided by 2. Okay, do not forget that divided by 2. So the volume of this one is going to be base times by this height here, divided by 2, because it's a triangle, times by the depth. If you want to simplify that, it would be big HD over 2. And you will need to know all of these volumes for this next part, because we're going to be working backwards, and it's all about, with any of these questions, any of them at all, it's about using one of these formulas, so picking one of these formulas, substituting in everything that you know, and then, once you've got them, you work backwards, so you solve it like an equation. If you haven't, this page here is pretty much everything you need to know as a starting point with volume of a shape. So this, if you haven't got this down, I'd probably get this down as a page in your notes, because this is kind of here the everything you need to know. All right, super. So let's just start having a go at these questions. Now, some of these first ones are a lot easier than the harder ones. Okay, so I'll make this big for you. Here's our first one. So here we've got a cylinder with a height of 10 and a volume of 100 meters cubed. What is the radius? So you might have seen this one when we did volume of a prism working backwards. I am going to do some more of these just because they come up quite regularly. Especially we need this towards the end of the last. We need this for the end of our other questions. So let's draw this out. This is example 1. Remember to get these examples in your notes. I'm starting to sound like a broken record with this, but the only way to learn maths is to do it. So we've got our cylinder here. We've got our radius there, which is r. We've got our height, which is 10. And it's telling me the volume is equal to 100 meters cubed. So I'm going to keep referring back to this. So today, it's all about getting the formula, substituting in, and then working backwards. So this is the formula I'm looking at here for this one. Volume is equal to pi r squared h. So let's write that down first of all. Volume is equal to pi r squared, so the area of this cross section, times by the height, which is h in this case. Let's substitute in everything we know. So it's going to be 100 is equal to pi times by r squared times by h, which is 10 in this case. Notice I'm using mini brackets here. I love using these mini brackets. You can put that straight into your calculator. Now, we've wrote our formula, we've substituted in, and now we're going to simplify so we can work backwards. So pi times by 10 times by r squared, that's the order you'd probably do it in. So it'd be 100 is equal to 10 times by pi, which is 10 pi. I can't do anything with that r squared, so I'll keep it as r squared, like so. So now I'm trying to solve this. Solve means to find r unknown. So we're trying to solve this to find r, so I'm trying to find out what r is. When I do that, I need to get rid of this 10 pi. So I divide by 10 pi, I divide by 10 pi, dividing the right hand side by 10 pi gets rid of that, dividing the left hand side by 10 pi, do this on my calculator. So it's going to be 100 divided by 10, shift pi, there we go, is equal to 3.18. And I'm going to do it to 3 decimal places for now. 3.183 is equal to r squared. So then what is the radius? Well, I need to find this, I need to square root this now to get rid of this squared. So I'm square rooting both sides. That gets rid of that. So r is equal to the square root of this. So square root, shift, answer. Not percentage sign. Square root, no shift, answer. Which in this case, r is equal to r is equal to, I'm going to do it to 2 decimal places now, just to keep it neat. 1.7, does it say? No, it doesn't. 1.78 centimetres. You can check that by going forward again. You can check that if you wanted to. Just make sure we know that's right. 1.78, brilliant. Okay, so that's the first example. Let's have a go at another one. We've got 2 more here. What I'm going to suggest that you do is pause this now, have a go at these 2 yourself in your book. If you still feel as if you're struggling with this, I'm going to do both of these in a second. So pause now, have a go at them yourself. If you're struggling, then you can copy them down. I'm going to do example 2 and 3. In fact, what I should do is make them big for you. Sorry about that. Okay, so let's have a go at these. This next one is example 2. So let's read this out. A dog tin is cylindrical and in the shape with the indicated length. So looking at this here. The manufacturer wants to make a new tin with the same volume but the radius of 5.8. What height should they make the tin? So let's draw this first of all. Here we've got a cylinder, remember? You draw it 2 ovals, connect them up. It's telling me that the radius of this is 6.5 and the vertical height of this is equal to 11.5 centimetres. So it wants it to be the same volume here. So the first thing I'm going to need to do is to work out what the volume of this one is. So the volume of this is going to be the cross-sectional area times by the depth, which in this case the volume is equal to pi r squared, because this is a circle, times by the depth, which in this case is the h, the height in this, pi r squared h, that could be d, could be pi r squared d. And let's substitute everything in. So the volume is equal to pi times by 6.5 squared times by 11.5. Notice that I'm not using the time symbols here because it means I can type them straight into my calculator. Pi times by 6.5 squared times by 11.5. So shift pi times by, so you can see that, 6.5 squared. Notice that squared is outside of that bracket, not inside. Times by 11.5, which is equal to a big number in pi. I'm just going to write it as a decimal actually. Do it to 2 decimal places. This volume here is equal to 1526.42 centimetres cubed because it's volume. Centimetres cubed because it's volume. So this is what the volume of this is, but it's not asking that. The question is asking, it says it wants, so I'm going to just draw a little line here. It wants it to have a different cylinder, okay, with the radius of 5.8 with the same volume of this. So our volume is equal to 1526.42. And it's saying find out what the height should be. So we've worked out our volume is, and now we're working backwards, okay? So I write down what the formula is. Remember, the steps are formula, substitute in, simplify, work backwards to solve, okay? So our formula for this one is volume is equal to pi r squared h. Let's substitute everything in. 1526.42 is equal to pi times by r squared, my new r squared, which is 8.5 squared, times by h in this case. Let's simplify that. Now the only part I'm simplifying this part here, it is going to be a weird decimal. Okay. In fact, you could, if you wanted to, just divide all by that now. Okay. In fact, that's probably what I'm going to do because it's that times this. So it's actually probably better to divide by all of that first. So to find h on its own, I'm dividing by pi times by 5.8 squared. I'm dividing by all of that, and I've got to do the same on this side. Divide by pi times by 5.8 squared. And the reason I'm doing that is because it's just a little bit more accurate. So divide that side by that, which means that I'll get rid of that, and I'm dividing this side by this as well. So I end up with h is equal to all of this divided by that, which is 1526.42 divided by, using the fraction button, shift pi times by 5.8 squared, which is equal to 14.4. Does it say decimal places? No, so let's just do 14.4 centimetres. Remember, it's centimetres because it's the height. So, with this one here now, 14.4, brilliant. Okay, so we've worked out our volume. We then wrote our volume down, substituted in, then solved to find out what h is. I got rid of all of this at the same time by dividing by all of it together. Okay, that was example 2. Make sure that's in your notes. Okay, remember the only way to learn maths is to do it. Okay, let's have a look at this this sphere now. So here we've got sphere like this, radius there like that. And now this is actually the volume of the Earth. Okay, so it's saying that the volume of this now, and it's a big number, it's in standard form, is 1.08 times 10 to the 12 kilometers cubed. So it's telling you the volume, and it's saying what is this radius. So when I'm doing this, same as always, linking back to this one here, I'm going to write down the formula, substitute everything in, and then work backwards. So the formula for the volume of a sphere, volume is equal to 4/3 pi r cubed. That's the formula. When I'm working backwards, it's going to be 1.08 times 10 to the 12, substituting in, is equal to 4/3 pi r cubed. So I've substituted in. I'm now going to solve to work backwards. I'm going to get rid of all of this at the same time because it's that times by that times by that. So I can just divide by all of that. So I'm dividing by 4/3 pi. I'm dividing this side by 4/3 pi. You could, if you wanted to, times by the 3, then divide by the 4, then divide by the pi. You would need to do that if this was a trickier non-calculator question. Because this is calculated, because this is in standard form, I know I can just do it quickly. So if I'm dividing the right-hand side by this, it gets rid of that. Divide the left-hand side by this. So let's just make sure we're getting this right when we're typing it in. Okay, so fraction button first, sorry, because I'm dividing. So fraction button, 1.08 times by 10 to the power of 12. Okay, that's right. Divided by 4/3. So fraction button again, 4/3 times by, notice I press right there, times by shift pi. So that's going to give me the radius cubed. Okay, so here I have the radius cubed is what's left over, is equal to, I'm going to do this to 2 decimal places, 2.58 in this case, times 10 to the 11. Notice I've rounded that up, 2.58. Okay. Next thing I need to do is get rid of this cube. Now the inverse of cubing is cube rooting both of these, cube root both of these. So I'm going to cube root my answer, which in this case, my radius is equal to, get rid of that, 507770. So what's that? 507,770 is equal to my radius, and that is in kilometres. Brilliant. And that's that question done. Let's just check the answer on that. Where have I made a mistake? What a silly Billy I am. Look, I've wrote cube root, and what did I do? I square rooted my answer. What a plonker. So, cube root 2.58 times by 10 to the power of 11, which is this. R is equal to 6366.1 kilometres. Super. Alright, so we've done questions like that. Here are some questions on here. We've got some surface area ones here. Make sure you're using the formula for the surface area and just working backwards. If you're not sure what the formula for the surface area is, here they are. So the surface area of a sphere is, let's write this up here, surface area is equal to, we did do this in our previous video, 4 pi r squared. Okay, that's the formula for that. So for question 4, you use this formula, then work backwards. Okay, doing exactly the same technique. Which ones have we got the surface area for? Surface area of this. So we've got the surface area. In fact, I've actually got a slide for this. Let's get this up. Go back here. Here it is. Here's all of them. So this one here would be a little bit trickier. So you'd find the curved surface area, which is pi RL, so pi times R times L, and then you would need to add the area of the bottom, which is pi R squared. That one there's a little bit trickier. They are quite tricky, those. These are all the things we've done recently. This is question 6. Really tough there. So if you wanted to know the curved surface area of the cone, so the curved was equal to pi RL. So you need the surface area of all of this is the curve, which is pi RL, plus the area of the bottom, which is this. I will write that formula down. Where am I going to do that? Surface area of a cone is equal to pi RL. Pi R, where this is the length here, L, plus pi R squared. Okay, that's the surface area. That's for 6. That's the formula you'd be starting with on this. It is tough, that one. If you can do that, I'll be really impressed. So have a go at these questions then. Pause now. And I'll release the answers. Well done if you got 6 and 7 right. They were really tough. Okay. So, let's move on. So, here's our next question. And the next kind of questions, and this is the last part of this. This is these are the hardest type of volume questions. And usually, what happens is you have one shape, you have another shape, and you've got to find the volume of one shape. They're the same volume, and then you work out a dimension or something in the other shape, or you've got to do it algebraically. These are the toughest ones. So this one here, I want you to get down in your notes. This one here is example 4. So here, we've got a sphere with a radius of 3 kilometers. And we want it to be a cuboid. So remember to draw a cuboid. I draw a square, up and right, another square, and connect them all up. Like so. So first of all, I'm going to find out the volume of this. Going back to this sheet again, I'm going to keep referring to this. The volume of this one is 4/3 pi r cubed. Let's write that down. Volume is equal to 4/3 pi r cubed. So the volume of this one is equal to 4/3 pi times by 3 cubed. So, fraction button, 4/3 times pi times by 3 cubed. 4/3 pi r cubed. See that? There we go. Which is equal to 36 pi. I'm going to keep it as 36 pi for now, just because it's more accurate. Now, if you want the volume of a cuboid, it's going to be the cross-sectional area times by the depth, but we know that all of these are x, x, and x. So the cross-sectional area is x times x, which is x squared, times by the depth, which is going to be x. So the volume of this one is equal to x cubed. And again, what we do is we sub in our volume and then work backwards. So it's going to be 36 pi is equal to x cubed. And to find out x, I'm going to do the inverse of this, which is going to be cube root. And cube root, I'm not going to make the same mistake again. Remember to cube root it this time. Cube root of 36 pi is equal to x. I can actually hear my wife upstairs laughing at me, calling myself a plonker. So, the cube root of 36 shift pi, I've done it again, look. The shift cube root above it, of 36 pi is equal to x, which in this case is 4 does it say the dimensions? 4.8, that's going to be kilometres, isn't it? 4.8 kilometres. Let's just check that. Oh, they've left it for cube root 36 pi. So that's example 4. Let's move on to a trickier one. Now this here is where it really steps up. Okay, these questions are tricky, but they always come up, and that's why we've got to focus on them. This one here you must get down in your notes. Okay, so I'm going to make this big. So the diagram shows a solid metal cylinder, and it has a base radius of 2x, a height of 9x. The cylinder is melted down into a sphere of radius r. Find an expression of r in terms of x. So, get this one down. I think this is example 5. These are the tricky ones. So here, let's draw this out. Cylinder, oval, oval, up like that. 2x, height of 9x. This is the radius of this, and it's been melted down to make this sphere with a radius of r. And it's saying, what is r in terms of x? So the first thing, linking back to this again, I'm going to keep going back to this. So I'm going to be using this formula. I'm going to be using this formula for a cylinder and for a sphere. So here we've got the volume of a cylinder, which is volume is equal to pi r squared times by h. I've got to be really careful with this one now. I'll show you why in a second. The volume of this one is going to be equal to 4/3 pi r cubed. So with this question here, it's very similar, but it's in terms of x, so it makes it that little bit more challenging. Okay, so we substitute in our values. Notice previously I used those mini brackets. Okay, this can come up on non-calculator and does come up on non-calculator. So we're going to stay away from our calculator with this one because we don't know what these values are. Everything's in terms of x. So the volume of this one is equal to pi times by my radius, which is going to be 2x squared. Notice that I've put all of this in a bracket squared. Times by my height, which is 9x. Now it has to be this squared outside the bracket because a lot of people make this mistake and write this 2x squared, and they forget that it's all of this squared. It has to be the whole of the radius squared. We can't just write 2x squared. It's not the same. That is not the same. Okay? Stay away from that. So we have here this squared. So volume is equal to pi times by 2x squared means like 2x times by 2x. And 2x times by 2x is 4x squared. Like so. times by 9x. Now I can times all of these. So volume is equal to 4x squared times by 9x. 4 times by 9 is 36. X times by x is x cubed. So I end up with 36 pi x cubed. This is all in terms of x. And we're saying here that this is equal to this volume because it's been melted down. So I'm saying that this volume here is equal to this. So 36 pi x cubed, which is this volume in terms of x, is equal to 4/3 pi r cubed. So we've got to simplify this now because we just want this in terms of r. The first thing I notice is there's a pi in both of these. So I'm going to divide both sides by pi. Very similar to if we're cancelling this. So pi divided by pi is just 1. Pi divided by pi is just 1. So I end up with 36 x cubed is equal to 4/3 r cubed. The next thing I'm going to do is times up by this 3. So get rid of this 3 by timesing by 3 and timesing by 3. So if I'm timesing this side by 3, because this is non-calculated, I'm just going to make sure I do this right. 36 times by 3. 3 times by 6. 6, 12, 18. 8, carry the 1. 3 times by 3 is 9, so that's 108. So this is going to be equal to 108 x cubed is equal to 4r cubed. The next thing we need to do is divide by 4, divide by 4. Again, because I'm using non-calculator, I'm going to use the bus stop method for this. How many times does 4 go into 1? None, carry the 1. How many times does 4 go into 10? Twice, with 2 remainder. How many times does 4 go into 28? That is 7. So the answer to this is 27x cubed is equal to, got rid of that, r cubed. Notice that this is r cubed, so what I need to do now is I need to get rid of that cubed, and I'm doing that by cube rooting both sides. So let's cube root this, cube root this. Now cube root means what number do I need to times by itself 3 times to get that number? So what do I need to times by itself 3 times to get 27? Well, try 2. 2 times 2 is 4, times 2 is 8, so it's not that. 3 times 3 is 9, times by 3 is 27. So the cube root of 27 is 3, and the cube root of x cubed is just x, because it's x times x times x. What times by itself 3 times to get that number? So that's going to mean that cancels with that. So I end up with the cube root of 27x cubed, which is just 3x is equal to r. So here is what we've got. And that is tough. That is really tough. Okay? But it does come up. It comes up all the time. Alright. Got a couple more questions here for you to have a go at. I'm going to suggest that you pause this, have a go at these questions. I'll make it big for you so you can see it. Have a go at those questions. I'm going to put the answers up now for you. So here we've got 4/3 pi r cubed is equal to 1/3 pi x squared h. We then cancel the pi's. We also cancel the x squareds on both sides. And then we'd cancel times in both sides by 3 to get this. This next one, this one here is a little bit trickier because it's the surface areas this time. So this one here is 2 pi r squared plus pi r squared, so pi x squared, which is this one here. and that's equal to this one here, which is equal to pi x squared times by the h. Make sure you're having a good think about that one. That one's tough. Okay, I've got some more questions for you to have a go at here. So have a go at all of these questions. Pause now and have a go at those. Remember to mark these in green. I'm going to put these answers up. These are tough. They are challenging. So please persevere with them. Make sure you're pausing again to see that you've understood them. They are tricky, but it's worth it because these are going to be worth 4 or 5 marks. So make sure you really try with these questions because they are tough, okay? They are really tough. So make sure you're really thinking about them. Brilliant. So thank you for watching this video. Make sure you're really trying hard with these ones because they are tricky. I know I keep saying it, but make sure you're following the working. Pause if you need to, and have a wonderful day.